Today's lecture is going to be on mining, harvesting the earth, that the earth is very good to us. We need to realize we're looking at mineral resources, that our life is completely dependent on the earth providing us with materials. 99% of the world comes from being either grown or mined from the earth. So we seek out ores. These are naturally occurring solid materials from which a metal or valuable mineral can be profitably extracted. Because these resources are in rock, in the earth's crust, we have to go and get them. So here we'll see one type of mine, and here we'll see a shaft type of mine. So some common ores. They're found in ore deposits. An ore deposit is an accumulation of an ore. This is a distinct, let's just say this is distinct from a mineral resource. Most ore deposits are named according to their location. So we can have some funky names. Or it could be after a discoverer, the Cambalda nickel chutes, named after drillers, or some whimsy, historical figure, a prominent person, or something mythological. Even a silly name. We can say that one of them is called a phoenix, kraken, fiery dragon butt, and so on. So from these ore deposits, we can go after galena to find lead. We can go after bauxite to get aluminum. We can talk about going after hematite to get iron ore. Sphalerite is a zinc ore. And we can find this type of rock that doesn't even look like it contains gold, but if it's profitable, it's mined and harvested. And you literally just melt out the gold. So there are three primary types of mines. Here we see strip mining. Large machinery strips away layers of land to expose the ore, the mineral, or the resource. To the right over here we see open pit mining. Miners dig open pit mines to remove materials that start near the surface and reach deep underground. And here we have shaft mining, where we find ores, minerals, and resources that occur in veins and need a network of tunnels to access it. In other words, you don't need to start at the top. You can go and access it from the side, only in particular areas where you're going to find a high density, a concentration, where the profit margin makes sense. So once you have the ore, you pretty much have a bunch of rock. So then smelting takes place. So I'm going to go through a simplistic version. It'll reference this picture here. So the process of separating metals from an ore, right? The ore is the rock that contains the useful metals, or materials for this case. This is typically done by heating the ore to its melting point and separating the useful stuff from the rock itself. So smelting itself. Ore is dropped into the furnace, and it heats out, it melts out, it sweats out the valuable materials as a separation technique. The metal's melting point generally is less than that of the surrounding rock, so it liquefies and pours out. And the leftover slag is taken out of the furnace and the separation process is complete. And this graphic here just kind of shows you put your stuff in the top, you heat it, and you get this secondary effect of what it is, your desired component that you're trying to separate out. So from here, we begin making alloys. So you might see the word alloy described as a mixture of metals, but that can be misleading. Some alloys contain only one metal mixed with another substance. It can be a non-metal. So for example, cast iron is made of iron mixed with carbon and is an alloy, where carbon is not a secondary metal. So the best way to think of an alloy is that a material that's made up of at least two different chemical elements, one of which has to be a metal. So the most important metallic component, where it represents 90% or so of the material, is called the main metal, or the parent metal, or the base metal. The other components of the alloy, called alloying agents, can be metals or nonmetals and are present in smaller quantities, sometimes less than 1%. Although an alloy can sometimes be a compound, which is chemically bonded together, it usually is a solid solution, which is atoms of elements intermixed, like salt mixed with water. So if we look at the table that's in our binders, some common alloys here, we see that we've got all kinds of different materials we work from. We use these alloys in our lives. And here's their compositions. Notice these are generally metals that are mixed together, but they have different properties. So when you look to create an alloy, you're combining, in this case, different metals to get the uses of what we use in our life. Sometimes you need something that's really strong. Sometimes you need something that is going to be really durable. Or if we look at superalloys, great strength and durability. Right? Spacecraft use very specific alloys. Where in a home, right, in a house where we find stainless steel, well, you don't need the same materials as spacecraft, but you can use them. So when we talk about alloys in our lives, we're surrounded by alloys. Almost every material in the world that we could ever want or use is lurking somewhere in the planet beneath our feet. It just may not be quite in the usable form until we access it and make it into what we want to use it for. But it's there. From the gold we wear as jewelry, or even the grills, to the oil and gasoline that powers our automobiles. It comes from within the earth. Chemical elements are the basic building blocks from which all materials in the earth are made. There are 90 or so naturally occurring elements, so I can see the periodic table, and the majority of them are metals. But even as useful as metals are, they are less than perfect for the job. Take iron, for example. It's amazingly strong, but can be brittle, can break easily upon stress, and it rusts in damp air near water. Or aluminum, very light in its pure form, but it's too soft and too weak to be much use. So that is why the metals in our lives are actually alloys. Alloys are metals combined with other substances to improve their usability and functionality. They can be stronger, harder, lighter, or just better in some way. Alloys are all around us. And the last topic that we'll look at is a penny. A penny lost is $1 million industry. A penny is not what you think. From 1793 to 1837, a cent was made of pure copper. Newer pennies today are made of mostly zinc. According to the U.S. history and U.S. Mint, they've changed over time. Copper prices have gone up. So when we look at what changed in 1982, the alloy changed to mostly zinc and only 2% copper. The U.S. Mint was losing over twice the amount that the penny was worth in 2011. We can see it over here. In 2011, it actually cost $2.41 cents to create 1 penny because the metal values were increasing. So old pennies, copper; new pennies, zinc.